coefficients. If we have a polynomial with some unknown coefficients, like this polynomial with a p here, and p is some number, a constant, if we divide by some factor x minus h, then we get an expression for the remainder. But if we had another remainder, let's say it was 0, we can then just solve what we get to find p, okay? Here's a simple example. So it says, given x minus 3 is a factor of this polynomial, find the value of p. So if x minus 3 is a factor, that implies that f of 3 equals 0. In other words, the remainder is 0. So we can just sub in 3 and then make it equal to 0. So f of 3 is equal to 3 cubed minus 3 squared plus p times 3 plus 24, and that equals 0. 3 3s is 9 times 3 is 27, minus 9 plus 3p plus 24 equals 0. So 27 minus 9 is 18. 18 and 24 is 42. So we get 3p plus 42 equals 0. And therefore 3p equals minus 42. So p is minus 42 over 3, which we can simplify to 3 into 4 goes 1. 3 4s is 12, minus 14. And we're done there. Second example on finding unknown coefficients. Example 2 says f of x is px cubed plus qx squared minus 17x plus 4q. It says it's divisible by x minus 2 and the remainder is 6. And it also tells us another option, x minus 1 is a factor of f of x. Find p and q. So it's given us two options because there's two things, p and q. So we'll just use both, and then we're going to set up simultaneous equations. So let's use the first option, x minus 2. When it's divisible, x minus 2 is going to 6. That means that f of 2 is equal to 6. So we can just sub that in. We've got p times 2 cubed plus q times 2 squared minus 17 times 2 plus 4 times q equals 6. There's our first thing. Now we can just tidy that up. 2 2s are 4 times 2 is 8p. 2 2s are 4, 4q. 2 17s is 34 plus 4q equals 6. That's 8p plus 8q. I'll just take a 34 over to make 40. So there's one of our equations. Let's get our second one. X minus 1 is a factor. So that means that f of 1 equals 0. The remainder is 0. So we can just shove 1 in. So we've got p times 1 cubed plus q times 1 squared minus 17 times 1 plus 4q equals 0. Well, that gives me p here plus q minus 17 plus 4q equals 0. So that is p plus 5q equals 17, taking the 17 over. Two equations, and now we can just do simultaneous equations. 8p plus 8q equals 40, and p plus 5q equals 17. So we can either eliminate the q's or eliminate the p's. I'll just eliminate the p's by timesing this one by 8. So that gives me 8p plus 8q is equal to 40, and 8p plus 40q is equal to, call that 1 and 2, and we're just going to do 2, take away 1. So that gives me 40 minus 8 is 32q, and 136 minus 40, 96. So therefore we can just say that q is 96 over 32, which is 3. So we've got our q, so we can just sub it back in. So we knew that p plus 5q was equal to 17. So p plus 5 times 3 equals 17. P plus 15 equals 17. So p must equal 2. And we're done there.